Good afternoon and good evening, everyone, and welcome to Håkan and our first speaker, Heini. How are you guys?
Good, thank you. It's going
Yep.
well.
Yeah, pretty good. Very excited to this first session. I'm very excited to hear what we will hear from Heini.
Yeah, because it will be really cool today. Heini, you're going to start with introducing us to the world of mathematics and
Yes.
talk about algebra. How
Mhm.
did you get started with mathematics? How did it become your dream to work with?
Very good question. It was just always quite easy and fun to me, so it just kind of went that way. It wasn't really like it came very naturally, I have to say.
Yeah, there are not many people that can say that maybe, but I think that's why we are here, to make it natural for everyone
Yes, that's the plan.
to get into the world of mathematics as well.
Yes.
And I suppose
And
you have quite a unique background to teach about this, Heini. Can you tell us a little bit?
Yeah, so I studied math and I studied to become a math teacher. And once I graduated, I actually hopped over to the IT world and have been working with Azure and on the both infrastructure and data side for the past years. So I'm really excited. I kind of get to bring those worlds together and really kind of take those steps to make everything within machine learning and data science, like algorithms and things like that, really build that knowledge to make it understandable.
Yeah, nice.
yes. So, how are you doing, Håkan, by the way?
Yeah,
Are you ready for today?
yeah, I'm really excited about this to get it started. So
Yeah, it will be pretty exciting today because we are going to start from the beginning to build ourselves up to become an AI engineer or data scientist. So that's going to be pretty excited. So what do you think, guys? Shall we get started?
yes,
Or let's wait a little bit more. So yeah, maybe we can get started and
yeah, sure.
let's see.
That's
Hi again. Welcome to the first session of AI 42. Håkan, would you like to get started to introduce us?
Yeah, sure. So AI42 consists of two Microsoft AI MVs. It's me and Eve, and yeah. So what we've done is, the idea here behind AI42 is we want to give everyone here on the planet a chance to get into the interesting world of data science and machine learning. And the way that we're going to do this is we will be streaming 2 times a month on Wednesdays, and on each stream we will invite an industry expert or a recognized speaker that will be speaking about one particular subject. So what kind of subjects will we hear about, Eve?
Thank you, Håkan. So we are going to build your knowledge up from the very basics, starting from mathematics and statistics and probability calculations. And we're going to walk through the whole path to get to the end of the path when you become a data scientist, a data engineer, or an AI engineer, whichever is preferable from your side.
Yep. And also one idea here is also that you should be able to jump into this regardless if you're a complete beginner or if you already have some knowledge. So we'll start out with introductory stuff, and then we will go into more intermediate stuff, and then we'll also have some practical workshops, and then we also have some more advanced topics at the end of these things. And maybe Eve, do you want to tell us where can they find out more information about us?
Sure. First of all, you can, of course, find us on Instagram, Twitter, and Facebook. And it is a good idea to follow us on these social medias because there we are going to share all our upcoming events and some information. How can you sign up? What might you need to make your setup to be ready for these sessions? And maybe some extra information that you can use to improve your knowledge.
Yes. And then we also would like to take the opportunity to thank our sponsors. So we're sponsored by Microsoft. And all of the graphic design that you can see here on our stream has been designed by Devente Pongor. If you want to know more about that, you can visit his site here. And the intro music is composed and performed by Mina Marie. So with that said, I think we can go back to Heini, or what do you think, Eve?
I have one more thing to add before we continue, because there is something very important, because it's not just AI42 who is doing something to get you further in the field. We are in partnership, in close partnership and in collaboration with other meetups and communities as well. For example, we are in close collaboration with Global AI Community, but you might see us at other meetups and events from all around the world, showing us that as a collaboration together with them. I think that's all from my side for now. So I think it's time to get into it and get Heini in the stream.
Yes.
Hi, Heini. How are you?
Still good and ready to go.
Are you excited?
Yes, of course. Math is exciting, right?
Yes, it is. Yes, it always was exciting. All right. Do you want to give us an intro of what you're going to tell about?
Yes. So we are having the first mathematics session on algebra. And today is really about having a little fun, setting the stage, laying the foundation, and just taking those first steps into the world of math and kind of seeing how we can start to move towards all the exciting data science and machine learning and AI stuff from that base. So really
that sounds pretty exciting.
Yeah.
Yeah, that's cool. I think I can say that please everyone should have fun today. And let's enjoy our first session at AI42 Mathematics about algebra. Are we ready to go?
Yes.
Heini, take it away, please.
Thank you, everyone, and good evening or good morning, whatever the time of the day might be for you from my side as well. Welcome to the first lesson of mathematics, which will be around algebra. And I'm going to make a wild guess here that you might not have been drawn here just because of the algebra part, but also because of the whole stage of this will be leading you towards data science and AI and so forth. It will be building you some other skills than just be able to, for example, solve equations by themselves. So really, why are we so interested about mathematics when we're talking about AI and machine learning? Why do we care? So really, if we think about one kind of machine learning scenario, let's say that we have a set of data available and we're graphing that out into a nice plane. It's kind of simple data, not many dimensions or anything like that. We have this beautiful set of data, and we start to want to find a good, choose a machine learning algorithm and train our data. I mean, have our training data to train that algorithm and then have that solution for also predicting to the future. So we have to have some way to kind of find this trend from our data, find how is this data distributed, and find what kind of function describes it the best. And so the issue here is, well, how do we even start with this? But in this scenario that we have here, of course, the main question is then, how do we find this line? And the nice thing currently is that we have a lot of tools which we can use to do these automatically behind the scenes. We don't necessarily need to be need to know a lot of math to do that. It is enough for us to have just some basic knowledge and know how to use the tools which we can use to find that line. But it does help for us to gain some understanding about what happens beneath the surface, because then we can understand the restrictions that might be in place for using a specific algorithm, etc. So that is why we have these mathematics sessions lined up for you. And we will be starting these with today's session, where we will be walking through some basic algebra. As I said, we'll be kind of finding our ground, getting started, getting comfortable, just kind of playing with math today for the most part. The next session that will be coming up will be then going to calculus. After that, we will be going to linear algebra, which will allow us to solve much more complex scenarios than just kind of lines with two variables. And then after that, we will be also going into statistics. And then the last part will be about probabilities. So welcome from my side. I'm Heini. I live here in Finland. It's been snowing nonstop for the last 24 hours, I think. I work as a solution architect at Atea Finland, and as I mentioned, I work with Azure technologies. I am also a Microsoft certified trainer, so I train around Azure and architecture quite a lot as well. And that is kind of my passion. My other passion is very much mathematics, and it's kind of, I'm a math nerd at heart still, even though I don't teach math every day anymore. But that is also why it was so exciting to get this opportunity to lead these sessions. And you might see I'm a bit of a serial doodler. You'll find some of my drawings along as we go here. And I hope you enjoy the ride. If you want to ask any questions along the way, please do feel free to do that and post those in the channels where you're watching. Even Håkan will be keeping an eye on those and relaying them to me so we can address them at the right time. So let's get started. In this algebra session, we'll be laying the foundation, getting comfortable, and really just having fun with math. We will begin with a little kind of mathematical calculations and fun theories, so we can just get a feel for math and what we use it for. After that, we will be looking at sets and intervals. Then we will be going into algebraic expressions and how we evaluate and simplify those. Then we will be looking briefly at algebraic identities. Then we will be moving into equations and functions. And then as the last part, we will be looking at functions, some graphical representations, and transformations. So even during today's sessions, we're already going to be moving towards how do we visually represent things, whether they're lines or parabolas or things like that. We're going to get over there already, kind of what I was showing in the first slide. So we're going to start with a little bit of mathematical calculations and fun theories. So what I'm talking about here is that if we think about math, one aspect of math that is, it is attempting to describe real life, the real world to us. It's not, well, some parts of math are purely like theoretical and there might not be any implementations to it. But a large part of math is very much based on the fact that it is describing something in real life and helping us understand theories and how things work, etc. And that is very much what is true for when we're doing data science or machine learning. We might have data about the real world. And by using these theories from within data science or from these fields that we're going to be going over through in the next sessions, we'll be able to understand more about that data that we have. But in math, there is also these kind of systems where we have agreed on certain practices of how to do things. And one very simple example that we can look at is multiplication. For example, we use multiplication to describe areas of land. How big is something? Or we use multiplication to calculate our yearly salary, for example. We have many places where we multiply things. And there are very different methods for making a calculation in multiplication, for example. So we're not actually, in the methods that we use, we are not stuck to one way of doing things. Often we have many different ways of doing things. So for example, we're going to take a small example here. In Finland, when we're taught to do multiplication, we're taught to approach it like this. We put the numbers one under each other. We write 42 times 21, and we draw a line under that. And then we start doing calculations one number at a time using the lower numbers and starting from the right. So we start calculating 1 times 2. And from there we get 2. Then we calculate 1 times 4, from which we get 4. Then we move to the second number from the right on the bottom row. So we take the 2 instead. And again, we use that 2 to do the multiplication. First, we calculate 2 times 2. We get 4. And then we calculate 2 times 4, and we get 8. So we're essentially first calculating 1 times 42, and then calculating 20 times 42. And then we just need to add these two numbers together. So we get 2 from the right, then we get 8 from 4 plus 4, and then we get 8 as the last number. So we get 882. So this might be how you've learned to do multiplication, but it might not have been. You might have been taught a different kind of method. And there are other methods of doing this calculation. For example, there is this method called Chinese multiplication. And how this works is that we take these two numbers and we draw them out in a specific way, and that allows us to do the multiplication. So we first pick the first number from the left, 42, and we draw 4 lines for the 40 part of that number. And then we draw 2 lines for the 2 in that number. Then we take the other number, which is 21, and do the same thing. That means we draw 2 lines, and then we draw 1 line. And after that, we start to look at how these lines cross each other. So if we start from the left, we find that there are 8 points that intersect each other in regards to the lines. If we move to the very right, we find that there are 2 intersections on the right side. And then if we look at the 2 intersecting areas that are left in the middle, we can find that there are 8 points in total, 4 at the top and 4 at the bottom. And if you notice, yes, we have ended up with the same result as with our option to calculate this on the left. So you can see that the method of doing this has been very different in how it looks to the outside, but actually we are doing the same calculations behind the scenes to get to the result. So with math, you don't have to be so strict about how you go about it. You can get a little creative with your methods once you understand the systems and the rules that guide mathematics. But after that, you can get very creative with how you solve your problems. There's not just one way to do the things here. So we're gonna start with looking at sets first. And why do we want to look at sets? Well, sets are a collection of numbers. And really, if we think about collections of numbers, that is actually if we think about starting to work with our data. We often start with a set of data, and that data will have some kind of numbers, or it might have some other kinds of values. It doesn't really matter. We can also have sets of words. That's totally fine. But in mathematics case, we're often talking about sets, collections of numbers, of course. So some kind of collections that we could have, or sets, is that we could have, for example, a set of even numbers. That means we'll have all the minus numbers that are even, and then also all the positive numbers that are even as well. Or we could have a set of odd numbers. Another set would also be a set of prime numbers. So every number that is not divisible by another number. So 3, we cannot divide that by anything than itself. Also, we can have a more kind of loss of words here, a more restricted set. For example, the last example here is a positive multiples of 3 that are less than 10. So within that set, we only have 3 numbers included. And that is what is described in this picture here as well. And when we have sets, and these sets can be something that represents, for example, the data that we're working with when we're starting to work with data science. And when we have sets, we need to start to understand that data, and we need to start to explore that data and understand what kind of numbers are included and what kind of values in general. So for example, when we have multiple sets, we are able to start to look at, are there any overlapping numbers? And we can compare those sets that we are working with. And one way to do this is to look at the intersection of those two sets. And when we look at our sets A and our sets B, we can find that both of them have the numbers 4 and 7. And so the intersection of these two would be exactly that set that is made up of those two numbers, 4 and 7. On the other hand, we can look at what is the union of the sets A and B. So what are all the numbers that are included either in A or in B or even both of them? And of course, that we get just by putting all the numbers that we can find from within those two different sets and putting them all together. If we happen to have a third set, we can bring that into the picture as well and start looking at, well, can we find any overlaps there as well? And for example, in this case, if we look at the intersection of all those 3 sets that we are dealing with, A, B, and C, where the C had just the numbers 7 and 8 in them, then we can find that the only number that can be found in all 3 sets is actually just 7, but we can mark that as a set as well. And so a lot of the preliminary steps in data science have to do with understanding the data that you're working with. These were just very kind of the first simple steps that we might do, but there are many different techniques that we will get to at a later point about how we can discover things about the data that we're working with. In some scenarios, we might have data that is it's not so discrete. It's not exact values, it might be more continuous. And in that case, we might need to handle intervals. And intervals are sets that consist of all values between certain endpoints. So with numbers, we say that these are all the real numbers between a given pair of numbers. So for example, we could look at a number line that has 2 points marked there, and an interval between the 0 and 20 would be every number from between there. And then we could be checking, well, can we find our value within this interval or not, for example. And in this picture, you might note that the left side circle is not colored, it's kind of open. And that's a way to mark that the 0 is not included in that interval. And there are actually other ways to mark this kind of interval. So this is all numbers from 0 to 20, not including 0, but it is including 20. And one other way to mark this is to use brackets, where the 0 side bracket is facing outwards and the 20 side bracket is facing inwards. But there is also another syntax that is used. So it is possible that you might also see it in this format, where the open side just has a parenthesis, and then the side where the number is included, that is marked with the bracket. And just as we were working with the sets, we can also with intervals look at the overlapping if we're working with multiple of these, where these overlap, or what is the entire interval if we combine 2 of these. So for example, if we're gonna take one interval here, and we're gonna be drawing, let's say, we have points 0, 5, And let's put 10 in there. And let's say that we have one interval which is going from 0 to 5. So let's put it on both scenarios so that those are, whoops, closed. I'm not sure what's happening with my drawing, but let's say those are both closed. Don't worry about that. And let's say we have another interval, for example, going from, let's say that is a 3. We have another interval going from 3 to 10. Then we can look at what part overlaps with those two intervals. And from here, we can see that it is the space between 3 and 5. So for example, then we could mark that the overlap for these two intervals is from 3 to 5. And in the same way as we were working with sets, we can also look at other capabilities as well. Next up, we will be moving to algebraic expressions. And these are something that if you've been to math class, you've probably come across, but you might not have thought of them so much further. But these are where we're really setting the basis for understanding functions. And with understanding functions, then we're starting to be able to understand also the algorithms that we use for machine learning. And for example, how do we find that line, as we were asking in the first phase. So here are some examples of algebraic expressions. You might have seen something like x squared plus 3x minus 2, or something like 5y plus 1. These are both algebraic expressions. And of course, there are many more. But what makes an algebraic expression? So an algebraic expression is made up of terms, factors, and constants. Well, a bunch of weird words again. And so if we look at terms, these are the elements in an expression that are separated by addition operators. And the factors are separated by multiplication operations. So if we look at that definition, we can find that, for example, from our first example, x squared is one term, 3x is one term, and minus 2 is one term. If we look for factors, we can find that the 3 in front of the x is a factor because 3x is the same as 3 times x. We just don't need to show the multiplication mark. And we also have one constant here, which is the 2. So constant is somewhere where we don't have any of these letters or variables represented in the expression. Oftentimes, we want to evaluate some of these algebraic expressions. So, for example, we might have an expression that states 2x plus 4. And we want to find out, well, what is the value for this when, for example, this x is minus 2? And so how do we do that? We take this value that we want to evaluate this expression with, and we just pop it in where our x is. If we had multiple x's, we would just put it in multiple places. But in this simple example, we'll just put it in that one place. And whenever we're putting in these values for variables, we want to ensure that we're having parentheses around them, just in case we have these minus sign values, for example. So now we're just able to go ahead and calculate this. So we first calculate 2 times 2 minus 2, from which we get minus 4, and then we do plus 4, which ends up being 0. So when the value of x is minus 2, then this algebraic expression of 2x plus 4 equals 4. All right. Sometimes we might also need to simplify algebraic expressions. We might be given a really complex expression that has multiple terms, multiple factors, multiple constant as well, and maybe even some parentheses in there, and you need to figure out where to start. And oftentimes we want to start with removing parentheses if there are any of those present. And so within here, we have kind of the end part of the expression where we have the x times and then in parentheses 3y minus 1. And so we take the x and multiply 3y by it, and we also multiply minus 1. And with that, we are able to keep the first part as it is, and then just have that multiplication written out at the end. And then we can just calculate those out and just show them in a nicer order. For example, if we have x times minus 1, that is the same as minus x. Then after that, we notice that we have these terms that have the same variables in them. So for example, we have 5x and we have minus x. And that means that we can combine some of these terms. And how we go about this is we first identify which ones are like terms. So we notice those two. We also notice there are some y's in there. And then there are also these xy combinations as well. And so first, we just want to reorder everything. We have the like terms one after each other. And then after that, we'll be able to do the calculations. So 5x minus x, we get 4x, etc. So we just calculate each of these together. And for example, we have the 2y minus 2y. That ends up to 0 again. And then as the last point, we have the xy's. Again, we have minus xy plus 3xy, and we end up with 2xy. And then we just leave the constant. So by doing this simplification, what we're ending up with is that these two expressions that we had, this one here, whoa, we'll get there in a minute. This one here at the top, this one is exactly the same as this one here at the bottom. They are equal. Even though they don't look the same, they are equal. Because we have this capability of marking certain expressions as equal, we actually get things called algebraic identities. There are a list of these identities where we can say that this expression is equal to this another expression. So for example, one of the familiar ones you might have come across is this expression of, I'm sorry about that, I have to learn how to handle this thing here. One familiar thing you might have come across is the situation where you have x plus y squared. And you need to somehow be able to figure out the identity for this one. So how we go about this is the same as we do with simplifying equations. And we use the same rules as before. We first want to remove the parentheses. And to do that, we need to know that the x plus y squared, the squared means that we have x plus y times x plus y. And that is just one of those agreements within math that has been made. This is what the squared means, multiplying the same thing by itself twice. And after that, we're going to do the same thing as previously. We're going to take the x first and multiply this x here. And then we're going to multiply the y here with it. So we get x times x plus x times y. And then here as the second step, we take the y and multiply the x there. And then we multiply the y there as well. We want to go through all the terms that we have here. So then we get y times x plus y times y as well. And then we can just simplify these again. As we have x times x, as we knew in the first step, this can be marked with x squared. X times y is the same as y times x. So we actually have 2xy. So we don't need to write the multiplication marks between the different terms or the different variables. That is also an agreement. And then as the last point, we have the y squared as we have y times y. So we get this equation where we know that, well, x plus y squared is the same as x squared, 2xy plus y squared. You might have seen this in some mathematical books, and this is why it is true. But there is actually many of these algebraic identities, and here's just a brief list of some of them. We don't have time to quite go through all of them, but just know you don't have to remember everything by heart or do the calculations for everything by heart. You can use these algebraic identities that are available for us to use. And as we've been working with algebraic expressions and identities, the next thing we want to go into is equations and functions. And when we're talking about equations and functions, equations is just taking two of those algebraic expressions and just marking them as being equal. So for example, we could have a equation that says y equals x plus 5. That is an equation. We can also have many different kinds of equations. So there's one example, but we can have something like y equals x squared plus 3x, and so on. Again, it's just taking two of those algebraic expressions and marking them as being equal. And some equations will have a result, and some equations might not have a result. So it depends on what kind of equation you create. These equations that I wrote here, for example, have two variables. There's the x and there's the y. And these are the kind of equations that we normally are able to draw in a coordinate system, for example. And with these ones, we are often able to check whether they are functions. And something that we often don't think about is that equation and function are not the same thing. Functions are actually slightly different. And functions is defined as a binary relation between two sets. Again, there is the word sets, that associates every element of the first set to exactly one element of the second set. Okay, what does that actually mean? It's kind of this weird mathematical language here that is coming up. I know. So what it means, remember we were talking about sets. So it's saying that we have two sets. I'm just gonna write our first set here. I'm gonna learn this at some point, I'm sure. We have our first set. Let's say there's a 1. I made that way too small. Let's say we have a 1, a 2, and a 3 in our set. And then we have another set. Let's say we have a 1, we have a 4, and we have a 9 in this other set. And this is saying that it is a relation that associates every element of the first set to exactly one element of the second set. So if the 1 goes to the 1, it cannot go to any other element in that second set. If the 2 goes to the 4, it cannot go to any other element. The 3 can go to the 1, that's totally fine. But the 3 cannot then at the same time also be associated to 9. So each of these elements in this first set on the left, there can be only one item for them in the right one. So if they try to go across to 2 of these on the right, then it's not a function anymore. Okay, now we're good. It's a function again. So if we look at these two pictures that we have here, we have a coordinate system where we have an x-axis and we have a y-axis. So pretty much the x-axis is representing the first set, and the y-axis is representing the second set. So in this picture on the right, the left set is our x-axis, and then the right one here is our y-axis. And so we have to look at for a value of x, is there one value of y? And if we look at this picture on the left, if we take a value of 1 here, we can find just one y value. It's 1. Okay, that's good. If we take 2, okay, we get a value of 4 for the y, for the second set. And by the way, it looks like it's kind of this relation that we made on the right here. It might have been slightly intentional. Then we have this second picture here. So if we, for example, from here take 1 from the x-axis again, we can find a -1, but we can also find a +1. So that is not actually a function because we have 2 values for 1 value of x. It is still, there's still an equation that represents that relation, but it is not a function. And why we care about functions is because on functions we can do transformations. And that is when we are trying, we have that data set that we had in the very first picture when we started that session, and we have those points scattered in that picture, and we're trying to find the line. We need to be able to do transformations on that line. So I'm going to use a cool tool to show this because I'm not going to hand draw all these graphics here for you. So I'm using a tool called Algebra. And this is something you can use to draw graphs. And so I'm just going to draw a few kinds of lines and curves and things like that on this drawing board that we have here. So, for example, I'm going to do the first one for y equals 2x. Let's start there. Okay, we get a line that goes like this. Okay, looks good. Let's do another line. Y equals -2x. Okay, cool. That just got flipped, kind of reflected by the x-axis. Okay, that's pretty good. We can do something like that. We just put a -2 in front and we were able to flip that line. Okay, let's do a next one. Y equals 4x. Okay, we got a bit of a steeper line. So this one is here for the h there. That one is that one, and then we have the f here for the other one, for our original one. So we just made our line a little steeper. But what if we do 2x plus 2? What happens? Okay, our line moves up. So we have all these methods of moving our lines, whether it's we need to make it steeper, we need to make it less steep, or we need to move it up the y-axis, etc. We have ways to do this. Okay. I'm just going to hide all these because I want to see, does this actually work if we have something more complex? Because we kind of played around with a simple scenario. So let's do x squared plus, well, let's start with x squared. That's good. Okay, we get a curve, which is called a parabola in this case. This is actually the graph that we had in our slide that we were looking at. So let's try this. The first change that we did for our previous one was that we added a minus in front of our equation that we have. So we did y equals -x squared. Oops, wrong. There we go. And what happens? Well, it gets flipped by using the x-axis. Okay. Well, what happened here? So if we put in the 2x minus 2x, oh yeah, that could also be a flip by the x-axis. My first initial impression was just say it's a flip by the y-axis because they are closer to the y. But yeah, it's mirrored also by the x-axis as well. Okay, so that works for both of these ones that we've been looking at. Okay, then we put we multiplied the equation we had on the right. So we, for example, let's say we're gonna do 2x squared instead. There we go. And I'm just gonna take that out. So the one that goes closer to the y-axis now, that is our new curve that we put in. And as our line became steeper when we went from 2x to 4x, also our curves will become steeper in the sense that it will kind of be moved towards the y-axis as well. And then we had this last scenario here where we added a constant to our equation that we had. So we had x squared plus, let's do the 2 as well. Oops, that went to the wrong place. Nope. Let's do that again. There we go. Okay, and what happened? Our curve got moved up on the y-axis again. And that is exactly what happened also with our line here. 2x plus 2. Again, our line got moved on this graph. Okay, so we kind of discovered quite many cool things about what we can do with our functions and how we can transform them. And if we want to have kind of a list of the things that happen to these, we have things that happen. So if we add a constant after our function, then our curve will move up or down, or curve or line, depending on the scenario. Then if we add a constant to our value of x, note that is slightly different, it will move our line either right or left. If it's a positive value, it will move left. If it's a negative value, it will move right. If we add a, if we add a value in front of it, which we multiply the whole function by, then it will stretch our graph towards the y-axis. And if that value is between 0 and 1, it will decompress it. Then if we instead add that, that multiplication to our value of x instead, it will compress it in the x direction. And if it's between 0 and 1, it will stretch it. So it depends on what kind of transformation we do on the function, what happens to it. So for example, the transformations that we did was the very top one. So we moved our graphics up by adding a 2. Then we tested the third one of these. So multiplying it by 2, and that made both our lines and parabolas go towards the y-axis. And then we had the lowest one where we had the minus in front of our function, and that made that function flip by our x-axis as well. So we found all these useful transformations that we can use. So as we are progressing into this direction of we want to figure out how do we find the line, or if we have a different kind of composition of the data points that we have, it might not be a line that we're looking for, but some other kind of curve instead. And what we've been doing today is really laying the foundation for understanding what kind of different lines do we have, how do we find those equations for them, and also how do we start solving them if needed. But we do have some steps yet to take to really get to the point of how do we find this line and understanding the different algorithms, for example, that we can use. And that is what we will be building on in the following sessions to come. So I really want to thank you all for joining. This was a fun thing to get you started on this path of really looking into math, learning algebra, and taking the first steps towards understanding the concept for data science and AI and machine learning. And so, Håkan and Niv, thank you so much for having me for this first session.
Hi, Heini. It was really cool. Thank you a lot. We got a lot of comments actually, and
cool.
it was a really nice session. And I think we actually can learn something new, because I think I even got confused as well with something here, because there because there was actually a question at some point that is power of something a factor. And there was a word about power of things, factorials. And I myself thought that a factor itself is should be understood as something's factor, like a yeah. So could we revisit this part and see what are these exactly?
So do you mean where we went with parts of the algebraic expressions? Is that
Yeah, I think that
Yeah,
okay.
I think actually, I think it's a little bit confusion here. What does it mean if you have 2 to the power of 3, for example? What does that mean? And also, what is the difference between a term and a factor? And then the last question is, what is a factorial? So I think these are the 3 different types of concepts.
Yes, factorials are something else. We'll get to them later. But within algebraic expressions, we kind of identify different parts of the terms. And so a term can have a factor. And typically we refer to a factor that is a number. So it actually has a value. So if there is a variable like an x or a y, we don't refer to that as a factor. If we have 2 to the third in front of an x, then that's going to be a factor for the x. But if we have, for example, x squared, that is just the variable part in that term. It is, we also have these kind of different identifications for different kinds of terms. So we can have a term of the second degree, I believe. I'm not sure of the terminology in English right now. It's just coming to me in Finnish.
Yes.
Unfortunately. We'll get back to that. So join us for the next session and you'll get more clarification about what happens when we get those terms with different kinds of powers and things like that. How do for example, the curves change when we get a third power or something else? It gets interesting.
Nice. Yeah, that's going to be something important, I think, to put it in place. We also got a lot of nice messages from a lot of people, and I'm again very thankful for everyone for joining us today. I remember that you have added this funny method how to multiply it to numbers, and we also got a comment on that what, never seen this method before. And such.
Yeah, exactly.
It's really cool. I think it's really nice to see different aspects when we are looking at different methods how to solve an equation or other mathematical issues.
Yeah, because sometimes math is viewed as such a strict thing, like there is only one way to solve it. But it's kind of, as long as we understand the rules, then we can get so creative with whether we visualize it in some way to help make it easier or things like that. And I think for understanding, for example, the concepts in data science and machine learning, it's so important to get that visualization to help us really grasp, because there's so many things happening under the hood as well.
Yep. Yes, definitely.
Yeah.
So do we have any other questions? Oh, yeah, we have another question.
Yes.
Let's put that question up here. So.
Yes.
Yeah, so the question is here. Yeah, so our next session will be in 2 weeks. So that will be on the 27th.
Yes. In the same time of where we are now.
Yes.
And then we got some comment here from Ashish. He said that I wish I could visualize math.
Oh, yeah. Well, I hope this will help, and join the next ones and we'll get some more visualizations. Definitely. Yeah, I think some of these tools that we have for visualizing things like the GeoGebra that I just showed are really neat, because then we're kind of just the equations in themselves. If we just see the equation, it's like, well, I don't understand what this is. So those are really great tools for just seeing what it would look like.
And we have some comments here from Jonah. She says, a great algebra review. Thanks for sharing.
Good to hear. Thanks.
Niklaus, thank you for the great presentation.
Yeah, I think we got a lot of nice feedbacks from everyone actually, and that's really nice of you guys. It's going to be really motivating to come back next week, 2 weeks later. Sorry. So what we are going to talk about next, Heini?
Well, the next step that we're going to be talking about is calculus. So we will be going into things like, well, we'll start off with just looking at a few more functions in the beginning. So we'll kind of continue on the topic that we left off on today. But then we will be going to things like derivatives and integrals. So those are kind of the two main topics for the next session. And that is always kind of a topic which can be a little daunting, like, oh, well, what is it? But I really hope that I can make that kind of visible and easy to understand as well.
Yeah, I'm sure about it, because today's session was really easy to understand. And that part of mathematics is one of my favorite, actually. So I can't wait.
Yeah, exactly. Perfect.
All right,
Yes.
guys. I really enjoyed this today. We learned a lot again from you. And yeah, we see each other 2 weeks later, again at the same time on Wednesday afternoon at 5 o'clock. And next time is again with Heini, and she is going to come back with the mathematics second part.
Yes.
Yep, thank you so much, everyone who was tuning in, and looking forward to see you in 2 weeks.
Yeah.
Great. Thank you.